Welcome back, guys. Today we're going to be doing a lesson on domain and range. Similar to the last lesson we did on function notation, this is a concept that's very important for you to understand for the rest of your high school math. We use this very frequently in both 20-1, 20-2, and at the 30 levels as well. So as you're going through the video, feel free to pause, practice some examples, back it up if you need to, and ask questions in class if you have any. Again, this is one concept I want to make sure you have a really strong understanding of before you head into 20 level math next year. All right, so the first thing we have to ask is, what is domain and range? Well, in the last lesson, we talked about the function machine, and that a function acts as a machine where we input some x's and we get y's out the end of the machine. And so we think about our domain as all of the possible x values that could go into that machine. And our range is all of the possible y values that could come out. And if you remember, when we're talking about y values, we can also represent that as f of x. So this is just a function. And so again, I'm looking at domain as all of the x values and range as all the y values. Now you might ask yourself, well, how can I remember domain as x and range as y? There's a couple ways that you can do that. Some students think about D coming before R in the alphabet and X coming before Y in the alphabet. The way that I used to remember it is maybe a little bit strange, but I tended to be a fairly messy writer, especially when I'm writing fast, and my G's often look like Y's, so I remembered range as being a Y. But however you do it, it's important that you understand domain is X and range is Y. So let's take a look at an example here. So I have a function, it says y equals x squared, and what I'm asking myself are, what are all the x values that I could put into that function? And then in the end, for range, I'm going to be asking, what are all the y values that I could get? Well, if I start asking myself what values can I put in, any number that I choose, if I plug it in, it should give me an output. So if I plugged in a 1 squared would give me 1, 2 squared would give me 2, 3 squared, and so on. So a better question sometimes is to ask myself, are there any numbers I can't put in there? And in this case, there are no numbers that I can plug in to y equals x squared that won't give me an answer. In other words, I can plug any number into that equation and get an answer. So all x values are possible. And so my domain would be all x values. Now then I have to look at the range and ask myself, what possible values could I have for the range? And sometimes this will involve doing some calculations with the function. So if I start plugging in some random numbers here, y equals 1 squared. Y equals 1 squared is 1. Y equals 2 squared is 4. Maybe if I go backwards, y equals 0 squared is 0. Y equals negative 3 squared is 9. Well, no matter what numbers I plug in, all of my numbers are 0 or bigger. So I can say that all of my y values are bigger than or equal to 0. And so if you're not familiar with your inequalities or you need some practice with that, I'd encourage you to make sure to look up some of that information online, or just make sure you're paying attention to that as you go through the video and make note of the patterns. But if we're thinking back to our inequalities here, we have 4 inequalities that we could be using: greater than, less than, greater than or equal to, and less than or equal to. And so when we're reading an inequality, we always read from left to right. And so less than is basically an L tipped on its side. And if a value is included, and we'll talk about that shortly, there would be an equal to sign. If I was writing out, for example, just a basic inequality, 4 and 3, and I want to say that 4 is bigger than 3, remember from elementary, you might have talked about the alligator always eating the bigger number. So we'll do the same with our ranges. If I want to say that y is bigger than 0, I can put the y, I put the 0, y is bigger than 0, so the alligator is going to want to eat the y, and in this case, it's also equal to 0. So it can be greater than or equal to 0. And so if we take a look at that example written out here, y equals x squared, all possible x's are allowed. And we can actually write that using something, or using an algebraic notation. And we can say this another way, and we can say that x is the element of reals. That's a fancy way of saying x is any possible number in the real number system. If you remember when we talked about number systems, there is another group of numbers called imaginary numbers or complex numbers. So we're just dealing with the real number system. Now, when it comes to domain and range, there are quite a few different ways that we can represent domain and range. And so I'm going to show you them now, but we're not going to actually deal with the specific notation until the very end of the lesson. So some ways that we can represent domain and range. The most basic and the one that we're going to use throughout most of this lesson is algebraic notation. And so the first one, to say that x is all real numbers, or x can be anything in the number system, we write x as the element of reals. If we want to say that y is greater than or equal to 0, that's what we've already written. So this would be the most basic way to write out domain and range. The next way that we can write it out is set builder notation, and you'll see this quite frequently, especially in Math 20. Set builder notation, we would read this as x such that x is the element of reals. And it's called set builder notation because we're using these squiggly brackets, which represent sets. And then for range, y such that y is greater than or equal to 0, and y is the element of reals. So that means all of the numbers that are greater than or equal to 0 are also in the real number system. And the last way that we can write this out is interval notation. And so for interval notation, I know it looks like a coordinate, but they actually have a different function. And so the brackets tell us whether something's included or not included. So a square bracket would represent something being included, so a number that's included, and a round bracket would not be included. And when we're dealing with infinity, we never use square brackets. So we had said with our domain that our x value could be all real numbers. So that means any number from negative infinity to infinity. So our low bound goes in the first position and our high bound goes in the last position. For our range, y was greater than or equal to 0. And so 0 would be our low bound, but it includes the 0. So we have a square bracket. And then it goes from 0 all the way up to infinity. So infinity would be our right bound. Again, that's just an introduction to notation. We're going to go through a bunch of examples related to domain and range, and we're just going to use the basic notation. And then at the very end, I'll show you a couple examples where I'll show you how we would write out our answers using all forms. All right, so the first thing we're going to do is take a look at domain, and then we're going to go into range, and then we'll put the two together. So when we're looking at domain and range, it's important that you remember the difference between discrete and continuous. Discrete data would look like a scatter plot. There's no connections between the points, so they're just individual dots on a graph. Continuous would be one long graph that we could complete without lifting our pencil. When we're looking at graphs, you might see open and closed circles. If it's an open circle, that means the value is not included. So if you hear me say open circle, that means it's not filled in. A closed circle would be included. And so that's important for us to know when we're doing our symbols. So in a dot that would be included would be using either greater than or equal to or less than or equal to. An open dot would just be using greater than or less than as our symbols. So let's take a look at some examples. The first example here, we have a series of 3 dots. There are no lines connecting between. So this would be an example of discrete data. And if it's discrete data, we just list the points. So we're going to create our set here. And so with discrete data, we're always going to use our set brackets. And our 3 points are -1, 2, and 3. So we just write -1, 2, and 3. And notice these are horizontal number lines. That's because these represent the x-axis. For B, we have a low number of -1, and it's filled in, so it's included. And we have a high number of 3. So to write this out, we're going to put our squiggly bracket again. We're going to write our lowest value of -1 and our highest value of 3. And that line in between means that all of the values between those are all possible values of x. And so we're going to put our x in between those two numbers. And as we go from -1 to +3, our numbers are getting bigger. So the alligator wants to eat the x because x is bigger than -1. And there's an equal to sign underneath because the dot's filled in. And 3 is bigger than x. So the alligator is going to eat the 3. But we don't put a line underneath this one because 3 has an open circle. All right, if we take a look at C, we have 2 open circles. And again, our x value is in between those 2 dots. So our low bound is -2. Our high bound is 1. X is in between. And in this case, there's no equal to symbol, but the alligator is still opening to the right. Now, if we have a graph that's going on and on forever in both directions, that basically means that every single number on that number line could be an x value. And so we just write this as x is the element of reals. And you'll see me put that extra line there. That's just a notation that I've used. But if you just write XER, that's fine as well. Make sure your E, though, looks like almost kind of like a C with a line in it. So that represents element. Okay, element. That just means that all of the x values are in the real number system. Now for the last example here, we have a closed dot at -3, and then all of our x values are getting bigger than -3, and -3 is included. When we have just one dot, we always start by writing the variable. You noticed everything else, we've been writing our low bound, then our high bound, and the x in between. When we have only one dot, so we're starting at a point and then getting bigger or smaller, we're always going to write it starting with the variable. So we're going to write x and the -3, and then we have to ask ourselves, which one is getting bigger? Well, all of the x values are moving to the right, so that means they're getting bigger. So all of our x values are greater than or equal to -3. All right, so we're going to take a look at range, and then we're going to put the two together. So at any point, if you need to go back and review the examples, feel free to pause and back them up. All right, so we're going to take a look at range, and you'll notice that the first part here is the exact same. Just remembering that discrete means it's a scatter plot. There's no connections between the points. Continuous would be one line. And again, included would use the symbols greater than or and equal to or less than and equal to. Not included would have no symbol underneath. All right, so we're looking at range. Range represents all of our y values. And if we're looking at all of our y values, that would mean a vertical line. And so that's why these number lines are up and down. For the first number line there, we have 4 distinct dots. And now we're using an R because it's representing range. Because it's discrete data, we're just going to create our set bracket and list the numbers. Now we often, when we're doing range and domain, we always list from lowest to highest. So we list things in numerical order. So -2, -1, 1, and 3. So -2, -1, 1, and 3. If we take a look at B, this one has a connection between the points. And so we know that those points in between, or in between the 2 dots, represent y. Again, we're talking about range. Our low bound is -3. Our high bound is 2, and y falls in between. Now for the 2, it's an open circle, and all of my y values are smaller than 2, so less than 2. And 3 is filled in, or sorry, -3 is filled in, and -3 is smaller. -3 is smaller than the y, or the y is bigger than, so we're going to have y is greater than or equal to -3 and less than 2. So the way that we would read this is my range is y is greater than or equal to -3 and less than 2. All right, so again, if you're needing any review or refresh, make sure you back this up. We're going to start looking at the different ways that we can represent domain and range using functions and and graphs and whatnot. So the first one we've already talked about is discrete. Discrete tends to be the easiest ones to work with because we're literally just looking for the coordinate points. With this particular graph here, for domain, you got to remember that domain is all of our x values. So domain is x, range is y. And so for domain, we're looking at all of our x values. Well, we have an x value at -3. We have an x value at -1, at 1, 2, and 4. So when we're looking at what our x values are, we're only looking where the data exists. And so we would set up a squiggly bracket or a set bracket, and we have -3, -1, 1, 2, 1, 2, and 4. All right, and for range, we would be looking at our y values. So we would be looking at those same points, but now we're going to look at where those y values are. So we have a dot right here, a dot right here, 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 and here. So our range, our lowest range value is -2. So -2 and -1 and 1 and 2 and 3. If you're given coordinate values already, we're just writing the x's where the domain is. So our domain here would be 3, 4, and 5. Now, if I have two 5s, I only need to write them once. And if you remember from the last lesson, because I have two 5s, that means this is not a function. We can still do domain and range even though it's a relation, but remember, if we have repeating inputs, this is not a function. So 3, 4, and 5, and then our range, we have a 5, a 10, a 12, and a 15. So 5, 10, 12, and 15. All right, moving on to the next type. When we're doing domain and range, we can also look at continuous slanted lines. So this is thinking back to our linear functions lesson or unit from the last unit. If I have a line and an angle this way, a line and an angle this way, these are a specific type of function. So they're linear functions, and they all have the same domain and range. If you think about our x values, if this graph is going on and on forever and ever and ever and ever and ever and ever and ever in both directions, every single x value along here will have a corresponding y value. So if I, for example, choose this x value here and I try to match a point on the graph, there's a point on the graph. If there's an x value way out here somewhere, and I were to connect a point, eventually it would touch the graph somewhere. So it does not matter what x value I plug in, I will have a corresponding y value. So that means that my domain is all real numbers. So my x values can be anything in the number system. And so the way that we represent that is x is the element of reals. And again, we put our squigglies around. For our range, we look at the same thing. We look at all the points on the y-axis, and there are no values on the y-axis that don't have a corresponding x. So this is also y is the element of reals. And so this is something that you may come to memorize, that for linear functions, if it's at a diagonal, my domain and my range are always x is the element of reals and y is the element of reals. The only time that wouldn't be the case is if it wasn't a continuous function, in that I had specific endpoints. But if the graph is going on and on forever in both directions and it's a linear diagonal line, then these are the domain and range. Now there are some special cases. If you remember from the linear functions unit, we were looking at graphing vertical and horizontal lines. Well, first of all, the vertical line is not a function, but again, we can still do domain and range. For domain, we're looking at our x values, but when we're looking at this graph falls right at x equals -2. And so that's the only x value that we have. So for this entire thing, x equals -2, because there's no other x values that correspond to that graph. And for the range values, if you notice, this graph is going on and on and on forever in both directions. So that means y is the element of reals. And for domain, when we have a horizontal line, that graph is going on and on forever in both directions. So it's going to cover every part of the x-axis. So x is the element of reals. Be careful, it's very easy to mix up your x's and your y's, especially when you're starting out. And then range, all of my y values are staying on this equation, y equals 3. And so my range is y equals 3. Because no matter where I look at that graph, anytime I pick a point on that graph, it will always have a y value of 3. All right, so another type of domain and range that you could come across is where there's specific endpoints. And so you can think about those almost as sandwiches. And we had already talked about these a little bit with when we were looking at domain and range separately. But sandwiches means that essentially we have divided our graph, or we've given specific endpoints to our graph, so it has clearly defined limits. And so what some people might do to help visualize is to draw a box. So I've seen some people that will take and draw a box around their, they'll draw a box around the grid, and that will help them to identify their domain and range. And so there's my box. I'll just change up the size here. And so there's sort of the outer limits of my graph. And so if I wanted to think about my domain values go from this x value here to this x value here. So those are my outside points. So my low point is -2, and my high point is +3. And we're talking about our domain, so that's all of the x values. So x goes in between, and they're both closed circles. So x is greater than or equal to -2 and less than or equal to +3. Now, when we're looking at range, we're looking at the range values, then we're looking at our limits based on, we're looking at our limits based on the y values. So we have a value here of +1, and we have a value here of 1, 2, 3, -3. So our range value, our lowest range value is -3, and y goes in between, and our high value is 1. Once you get comfortable using these, you don't have to necessarily use the bottom and top bound. You'll just be able to write it straight. -3 less than or equal to y less than or equal to 1. All right, let's take a look at the next one here. So again, if it helps, especially when you're starting out, drawing a graph or drawing a square or a box might help to define your limits. Now, this graph goes a little bit beyond the a little bit beyond that -2, so we could always estimate what that is. But if we're looking at our domain, our left bound here is just a little bit past -2, so you might even say like -2.2. In your assignment, all of the values are going to be clear-cut numbers. I'm not expecting you to work with decimals or estimate at this point. Our high point will be 3. And we're talking about domain, so that means we're talking about x's, so x is in between. The -2.2, that had a open circle, so that means it's just x is greater than -2.2, and the other one was a closed circle, so less than or equal to 3. All right. And for our range value, our low point is -2, and our high point, 1, 2, 3, about 3.5. So our low point was -2, and y, oh, we don't want the equal to sign there. So y is greater than -2 and less than or equal to 1, 2, 3.5. And again, you'd have your squiggly brackets. Now, the next type that we can see is what you can think of as a start and go graph. And so this is where you're going to have a very clear minimum point or maximum point, and the other part of the graph is going on forever. And so the first one here we're looking at is a parabola. This is a graph that you're going to see quite frequently when you get into Math 20. This particular graph has a low point right here, and that's the lowest point of the graph, and then everything else is getting bigger. But we're going to start off by looking at our x values. Now this is a parabola, and so if we were to draw a parabola, the graph is actually going on forever in both directions, and as it's going on in both directions, it's getting wider and wider and wider. So as this graph gets wider and wider and wider, it's going to ultimately cover every value on the x-axis. So every single part of this x-axis will have a corresponding value. I know that this doesn't show it this way because the scale is too small for us to see how wide it could get, but as it goes on forever, this graph will ultimately be getting wider and wider as we go. So with the parabola, x can be any value in the real number system, so x is the element of reals. Now when we look at our y value, we can't really draw a box because the box is would get infinitely wider, but we do know that there is a low point right here, and that's at -6. And then all of the other values are bigger than -6. So when we're looking at our graph here, the lowest point of my y values is -6, and then everything else is getting bigger. And so if I want to say that y is getting bigger than or equal to -6, I start with the y, greater than or equal to -6, and then squiggly brackets. For the next example here, this is a type of radical function, not the one that we deal with too much in grade 10, but you will see them next year. We have our x value here. There is a clear low point for x. There are no other x values back here, but we do have x values going to the right. So all of our x values are bigger than or equal to -1. So all of our x values are greater than or equal to -1. And our y values, when we look at our y values, there is no y values down here. There's no part of the graph that's down here, but there is a y value right at 0, and that's right here. And so all of our y values are getting bigger than or equal to 0. So you'd write y is greater than or equal to 0. All right, so that's all of the information for what domain and range is. And so those are the main types of examples that you're going to see. You're going to start off with discrete data. So if you've got your points, if you've got your coordinate points, you would just list your individual x's and individual y's. If you have continuous slanted lines, if they're at a diagonal, it's always going to be element of reals. X is the element of reals, y is the element of reals. Don't forget that there's the special case for horizontal and vertical. The sandwich cases we see quite often, especially in grade 10, so that when you're writing these out, you're just going to put your endpoints and then your variable in between. And make sure that when you're doing your inequalities that you pay attention to whether you have an open circle or a closed circle. And then there's the start and goes. And we actually see these quite often when we get into graphing different types of functions. So when you only have one max or one min point and it's not sandwiched between 2 points, you always lead with the variable. All right, so the last thing we're going to look at then is notation. And so, as I said before, there's 3 different types of notation. The most common that you'll probably see with grade 10 would be the algebraic notation, the one that we've been using, and interval notation. So I'll show you both. It does not matter to me how you show your domain as long as you can show your domain. So whether you choose to use interval notation or whether you choose to use algebraic notation, it doesn't matter to me. As you get further into high school, you'll get more comfortable with certain methods. All right, so for the first graph here, we have a start and stop graph. And so if we have a start and stop, these are often helpful to draw a box around your graph. And so if we draw the box here, we have our low x value there and our y value. And we're basically going to just draw like a picture frame around our function. And so from there, we can figure out what our low point is for x and our high point is for x. So our low point for x happens at -3, and our high point for x happens at +4. So we write -3, we put the +4 up higher, squiggly brackets, x goes in between, and we see that both of these are closed dots, so x is greater than or equal to -3 and less than or equal to 4. When we do our range, our low value for range is -2, our high value for range is +2, so we're going to go from -2 to +2, y is in between, and we fill in the rest of the information. So this is similar to set builder notation. If I was doing this with set builder notation, I would have a little bit more information to fill in. I'd have domain, squiggly bracket, x such that -3 less than or equal to x less than or equal to 4, comma, x is the element of reals. So I'm not going to spend a lot of time on the set builder notation. Often if you're required to use this, you'll see some type of example either in your notes or in a test situation. But as long as you can do the algebraic form, that's important. Now, if I want to write this information out using set builder notation, or sorry, interval notation, I'm going to still be thinking about my low bound and my high bound. So my low bound is -3. My high bound is +4. So I write -3, 4, and then I look to see what my dots are. These are both closed dots, so that means these are going to be square brackets. For my range, my low value was -2. My high bound was +2, and again, square brackets. For the next example, this is again a parabola, and it has a clear maximum point. So this is an example of a graph that is start and go. For domain, this graph again is going to keep getting wider and wider and wider. So my domain is x is the element of reals. And my range, I have a high value of 4, and all of my y values are getting smaller than 4. So I'm going to have y and the 4, and all of my y values are getting smaller than or equal to 4, so y is less than or equal to 4. If I was doing interval notation, if my graph can be anything in the real number system, that means it can be any number from -infinity to +infinity. And with infinity, we always use round brackets. For my y is less than or equal to 4, all of my numbers are getting smaller than 4. So my low bound is -infinity. My high bound is +4. Now, -infinity would always have a round bracket, but the 4 value is included, so we use a square bracket. So you're going to see round, -infinity, 4, and then square bracket. And the last example is another sandwich scenario. So we're going to start off with our algebraic notation. Again, if it helps, draw a little box around. And so we have our low bound at -2 and our high bound at 3. So -2 and 3, x is in between. And the 2 is an open circle, or -2 is an open circle, and the +3 is a closed circle. And for the low bound for the y's, I've got 1, 2, so -2. And the high bound is +1. I'm talking about range, so it's a y value. My -2 is an open circle, so that's going to be less than, or -2 is less than y. And the other one is a closed circle, so it's going to be less than or equal to 1. All right, so that's the lesson on domain and range. Again, this is a completely brand new concept, so I would anticipate that some of you are going to have some struggles with this at first. Practice makes perfect, and I strongly encourage you to come to class and ask some questions. We can work through some more examples and make sure that you have a good understanding. All right, thanks a lot, guys. Have a great night, and we'll see you soon.